Okay, so supply chain security, this is what we are talking about today. So today is a little bit more about security, and let's see what we can do here. So what happened in the past and what is a critical thing that is influencing more and more the developers and the daily life here. So I will give an overview here. I will explain a little bit what happened, what are the changes, what happened exactly during the last, let's say, 6-7 months since we have this interesting thing going on in the East, and some other information about masquerading techniques, infection methods, and all this stuff. So everything that is interesting for you as a developer. By the way, my name is Sven Ruppert. I'm developer advocate for JFrog. And as you can see, not only on the screencast, but I'm mostly out in the woods. And right now, this week, I'm in the Swedish forest because I'm on a recording trip. Okay, I have to record a few new videos. So if you want to see more videos in the woods with cybersecurity topics, check out my YouTube channel. I have a German one and I have an English one. Make sure that you're selecting the right one if you're subscribing. Okay, so there was one big thing. I think the most of you heard about it. It was the Solarwinds hack longer time ago. And I don't want to go into all the details, but the Solarwinds hack showed us a few things that are changing here. The thing that is changing is that, what happened with the SolarWinds for the people that not exactly know what was going on there. So SolarWinds is a company building up an Orion platform. Orion platform is an network management software, more or less, or a very critical piece of software inside a network to manage, monitor stuff. And customers of SolarWinds, they have big networks to work with. It's not only just a server, they have to manage tens, hundreds, sometimes thousands of servers. So on this piece in the middle, that's a piece of software, and this hacker group started to attack the SolarWinds infrastructure, and they broke into the network. They haven't stolen data, they haven't encrypted stuff or whatever. What they've done is they went to the CI environment, and in the CI environment, they just changed the build scripts. So in a way that with every new build, surprise, surprise, there was coming out a compromised binary. Then SolarWinds, a good thing, they have an automatic update, and they pushed this update to all the customers. Damn. In a few days, I think 2, 3, 4 days, they infected 12 to 15,000 customers from the 300,000 customers. And having in mind that at least 10, 12,000 customers would have networks, not only servers, this was a huge thing. So what is a key point for us here? So for us, we have to fight now against two things. We as a developer, we have to make sure that we are not consuming malicious stuff or vulnerabilities. We have to make sure that we're not distributing this stuff as well. And this is a big thing for us because we have to make sure that our customers, even if it's a part of a company, is not losing trust in us because we are just distributing shitty stuff. And well, who of you scanned his own Jenkins or CI environment once for vulnerabilities and started hardening it? I'm not sure about it. So the main thing that is important, since it was important before the pandemic, during the pandemic, it has a huge big wave. And especially during the last 7 months, we see a shift there as well, a very critical shift, is that we have to deal with supply chain security. So supply chain security in general is something that is the security along the whole pipeline of producing stuff. And producing stuff means that from the idea about third parties, the material, production line, down to the customer or down to the production environment where the stuff is running, there's a whole supply chain. And the whole supply chain has different security things that you should have in mind, and that changed a few things. For example, what we can see that more and more cyber criminals started to use these global events to coordinate or to use this environment or this theme to compromise your environments. Okay, this is one thing. But the other thing is that earlier days, it was more or less individuals that started, I think I can use this one. Give me a second. It stopped raining. It stopped raining. It stopped raining, so I can get rid of this noise here. So that these individuals started working together. So this groups start sharing information. They start sharing resources. They start sharing information. So they really start collaborating. And this is a new quality. So they're sharing resources to break into systems. And this is something that's really, really new. The motives to hack into systems was longer time ago more or less financial things. So they wanted to have some kind of money, more or less. They encrypted stuff and then they ask you for money and that's it. But since 1 or 2 years, we see that more and more these attacks are political motivated. And this means that they never want to have money. They just want to destroy something. And coming to the point that the hygiene in the security hygiene in these big companies is pushing the pressure to the left and right. It means to the small and medium business size company. So longer days ago, if I'm a small and medium business company and I'm just having 10, 20 developers, everything was fine. I hadn't take care about this stuff because I'm not interesting enough. Right now, with this high security border on this, especially since the pandemic and all the big companies increase the barrier dramatically, it's more or less a case that now the small and medium business companies are more and more attacked, but it's not only attacked by these individuals or cybercriminals. The bad thing is, especially during the last 7 months, we see that more and more attacks, political motivated, are in this way that if you're working for a big company or delivering to a big company that is working for the US government or is deploying something to the US government or whatever, and this is declared as unfriendly, you're not attacked by individuals or hacker groups. You are sometimes attacked by governmental organized groups. I don't know exactly how to describe it, but I think you got the point. So this is increasing dramatically the whole supply chain security stuff. But the supply chain security for us developers is a small part from this. It means that we have here more or less everything from I'm excluding the concept phase and just saying, okay, from piece of software until the binary is running in production, this is normally the regular supply chain, the software supply chain that we are working in. And here we have to think about what is in the hands of a developer. So what can we do? What are the points where we can work through? Okay, so we have the source code, we are coding software, we can have the secure coding concepts, we can have pair programming, reviews and all this stuff, but in the end we have source code. This source code is pushed to some kind of repository. In this repository it is stored and then grabbed by the build or CI environment to build stuff, and at this point we are producing binaries and we are consuming binaries. Okay, so, and then these binaries, what we are consuming is more or less pushed to some kind of package management, a repository or something like this. So in the end, what do we have? We have 3 things in our hands as a software developer. This is source code, binaries, and some kind of infrastructure. With the part of infrastructure, we have to decide by ourselves, do we have enough power to maintain this stuff? Do we have enough knowledge to harden this stuff? Yes or no? Then we have to decide if we are hosting this stuff by ourselves or we are going to the cloud or whatever. Okay, but in the end, the source code and the binary is complete under our control, and this is where we should focus on if we are thinking about security that we have in our hands as developers. So if you start reading about this stuff, about cybersecurity, cyber defense, DevSecOps, whatever the term is, we will see that we quite fast will get 4 main pillars that you will find in documentation. The first one is SAST, Static Application Security Testing, and this means you have scanners for vulnerabilities, malicious code packages, whatever, that is scanning all paths in your application, and the application is not running. So it's scanning all binaries, configuration, and all that stuff. Good, because you can do it immediately. So you can start quite early in your supply chain with this or in your production line. The bad thing is that it's hard to get the dynamic context of this. The opposite thing is dynamic application security testing. Here at this point, what we have is that we have the application running. And we have more or less this hacker approach. This hacker approach means that we're looking from outside at this thing, and then we just try to break in with most common over the most common vulnerabilities like SQL injection or whatever. And then we don't care about the technology that's used internally. We can't scan 100% of the application with us because we can just test from outside the API and then indirectly testing this stuff. And it's a little bit later in the production line because you need something that is running already. The good thing is you can do it on test systems, on staging systems, on production, whatever. You can use this dust environment on all stages. The opposite, or not the opposite, another thing that you should have in mind, the tool set mostly is some cloud-based tooling or cloud-based offerings. So it's very hard to modify the attack vectors you have. Maybe they're working a little bit with fuzzing. On the other side, you need it with internet connection. So a lot of tools from providers are not for air-gapped networks also. Okay, if you're combining both things like SAST and DAST, you will have something like interactive application security testing. It means it's something like security debugging. Look at it like performance stuff. Yeah, you're looking inside the application, you're running, you're modifying the workload. In this case, the workload would be an attack vector. This means in the end that the same with performance monitoring or performance optimization, it's nothing that you can just start from scratch and say, hey, I learned it now in 10 days and now I'm able to do it. So security, interactive application security testing means you need a lot of experience. You need different people that will train you so that you are not starting from scratch. And it will take some time until you can trust your own results. And it's not scaling because you need human interaction and you need a very special knowledge about the tooling with that you're using for the attack itself, how to modify the attack vectors. You need all this stuff. So it's not so easy. And the fourth thing, what you will find is RASP, Runtime Application Security Protection. Runtime Application Security Protection is something that is only usable on production. It makes no sense to use it on test environments or staging or whatever, because this is detection of an ongoing cyber attack. So what's the approach? Mostly you have an agent-based approach. It's something like an APM tool. It's modifying the bytecode on the server side, analyzing what's going on with machine learning in the background. They're analyzing what is actually ongoing, so what's happening right now, and then they will decide, okay, this pattern is not matching the regular thing, we have something, and then they can do two things. They can monitor an alert, send an email or whatever, or they can automatically shut down. And this is just application security protection. It's not testing anymore. So these are the four things. And if you're talking now about the different levels we are working on, we have to understand with this stuff, where is a machine good and where is the machine bad. Bad is a machine, for example, in deciding what is the best composition of use cases to microservice. Yeah? Because this is a domain-specific thing, and the machine is not good to decide, oh, it makes sense, this use case and that use case, to divide it or hold it together or whatever. So this is something a human has to do. On the other side, if you're going down to the layer of communication, for example, the machine is not able to decide it makes sense to send this two data over the same wire or send it over two different wires to make it secure. But what the machine can do is it can establish secured connections, it can handle with deals and all this, keys and all this stuff. And if you're going to the operating system, container-based infrastructure, then it's in a way that here the tools are stronger and stronger because they can implement resilience patterns, they can start respawning stuff, health stuff. So they can really work on a more generic level, and the tool stack is better. But the really full power of secure tooling right now, these days, is during the development phase. So during this DevOps phase or DevSecOps or whatever you want to say to it, here the tools are quite good because we are operating not on a domain-specific level, we are operating here on a pure technical level. And here are the tools very good. The main thing what you should understand is with all the convenience layers we have, a vulnerability can only be added, never be removed by an additional layer. And this means even if you're adding a second layer or the next layer to your application, you're able to make vulnerabilities inaccessible, maybe, but you can't remove them. So per definition, with every additional layer you're adding 0 or more vulnerabilities or malicious code package and so on and so on. The most people are forgetting here the DevSecOps part. So they're checking their own application, what they're producing, but they are completely ignoring, are you using a compromised compiler? What is with your build infrastructure? Do you have uncompromised build scripts and, okay? And here we have two dimensions again. Everything that is domain specific, the machine is bad. Everything that's pure technical, the machine is very, very good. So if you have this in mind, then you can start selecting different tool stacks. And the next word what you will get is more or less something like shift left. Shift left means that you start with this stuff as early as possible. Okay, so instead of just in production, you should do it during development. You should do it during the first line of code. So start with security as early as possible. And on the other side, security is nothing that you have in a dedicated state. So the term DevSecOps is a little bit wrong, because DevOps itself is a process, building, test, so coding, testing, building, blah, 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 all the steps. And security is not a step. Security is like quality, it's like performance. It should be in every step. So every single step has something to do with dedicated security issues. And you should go there in exactly this way. Okay. Now, if I think about my tool stack or my application, what I see is I have source code and I have binaries. The binaries are mostly organized in some kind of repositories, dependency management, because I have to address this dependency. I have to give it a artifact and group name and version or whatever the address of this binary is. And then I have some kind of resolver strategy, local repository, remote repository, some mirror side links, whatever, and so on and so on. And somewhere magically this binary is coming. And this is over all tool stack layers, Maven, Debian, Docker, blah, 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 the whole stack, okay? The most people, again, forgetting that for a good release, you should have, for example, in your release, the corresponding JVM compiler and so on as well. Only with this, you are able to really reproduce the environment if you have to analyze it or to recreate it and so on. So we at JFrog, we know it since a long time, and we are specialized in this environment, how to deal with binaries, okay, with Artifactory, the flagship product from us. And so it was a logical next point to go there with the security scanner, exactly at this Artifactory where we have all this information about the metadata, access to all the binaries, and so on and so on. We have a few things I want to highlight here is, I see in some projects that, for example, people have a very lean process in terms of producing use cases. So you have the description of the use case, and then you can freely decide if it is done, yes or no, and then you're pushing it to production and waiting for feedback from the customers. So it's a use case, it's a requirement, and everybody says, okay, you have the permission to do it. And then if you have a vulnerability, they're switching the process. I never got it. Why? So if you want to get rid of a vulnerability, it is like a use case. It's a requirement that should be pushed to production as fast as possible. Why? They start with slow process, like you need permission from this guy, from that guy, you need this and that, and so on and so on. It makes no sense, okay? It really makes no sense. So make this as fast as possible and use it in the same way with use case time to market. It must be changed as fast as possible and pushed to production as soon as possible, okay? If you are getting rid of vulnerabilities. Same with make or buy. We as developers, we have always think about, should I do it by myself? Okay, I can do it right, but I have to learn it. I have all the pain to do it. I'm doing all the mistakes again. Or should I buy it? I'm adding a dependency, okay? And then I have the challenge, okay, there is this use case. It fits mostly, well, okay, some compromise. But in the end, I have to trust this external dependency. Otherwise, I'm just, it's like flying in the dark, yeah? Okay, if you're not starting to implement some trust mechanisms, then you're just adding randomly dependencies and hoping that nothing is happening, okay? So what should you focus on first? If you're a developer and you're writing code, maybe 100,000 lines of code, okay, in your application, perfect, a huge project. But in the end, if you're counting all the lines of codes in your whole application, what you're writing by yourself and what you're adding as a dependency, you will see that dependency is mostly by far the biggest part, okay? And if you're going to the operating system, mostly you are just writing a few configurations and voila, the rest are binaries and so on and so on and so on. And the whole tech stack, compiler and so forth, is a dependency as well. So of the whole tech stack, checking how much lines of code and how many binaries or how much lines of code inside binaries you have, you will see that binaries are the most dominant thing. So if you start with security, it makes sense to focus on binaries first, because this is really the low-hanging fruit. This is the bigger thing. By the way, if you have compliance issues, it's more or less the same. It's not part of this talk, because compliance issue is more or less something, yeah, compliance, how to deal with license. But if you're hunting vulnerabilities, hunting compliance issues is exactly the same thing, okay? So what's the difference between compliance and vulnerability? So for example, if you have compliance issues, you have the challenge that you have somewhere in a tool stack something with a wrong license. The good thing here is it is just a single point and you can't combine different dots to a bigger thing, okay? But you have to change it in a way that you're removing this element. And you have to find a semantic equal implementation, and this is mostly painful. With vulnerabilities, it's a little bit easier at this point, because to get rid of a vulnerability, you just have to change the version of the same component. The bad thing with vulnerabilities is that different vulnerabilities can be combined, or they are combined to different attack vectors. So it means if you are just scanning one technology layer, it makes no sense, because you need the full impact graphs. You need to scan the whole tech stack, really everything. Only with this, you have enough information to decide if you have enough remediation and mitigation information to see what is really an active vulnerability and what is not an active vulnerability. The good thing here is that mostly you're changing it with version. The bad thing is if you're talking about malicious code packages, then we are more or less in the area of compliance issues. We have to replace it with a semantic equal implementation, okay? If you want to know more about the lifeline of a vulnerability, check out my YouTube channel. I have a talk about the lifeline of a vulnerability where I'm explaining all these different stages. The short version here is, what is a part you can influence and can increase the speed to get rid of vulnerabilities earlier? The first thing is, if you like it or not, you need to have access to a very actual vulnerability database in a way so that you can consume it. And mostly commercial vulnerability databases are faster and have more information than free vulnerability databases. If it is good, if it is bad, I don't want to discuss this one. But right now, this is a fact that the commercial ones are mostly way faster and have more information in. Nevertheless, whatever vulnerability database you're consuming, the moment that this vulnerability information is accessible and consumable by you is where the most time is spent on until the vulnerability is killed in production. So it means if you start focusing on killing vulnerabilities, automate the whole tech stack so that you really just switch versions, let all the tests run and push it to production. So this would be the bad thing. So far, we are talking the most time about vulnerabilities, okay? But there is a big thing coming, or there is something that is changing over the last few months dramatically, and these are malicious packages. Malicious packages are different than vulnerabilities, and this is something you should know, because intentional or unintentional vulnerabilities, these are mistakes or bugs in your code, okay? Unintentional because you are not following the secure coding guidelines. Intentional because you have different people that really try to sneak in with commits and all this stuff to do it. But malicious code is something more specific, and the big difference here is vulnerabilities will get an CVE, so an identity, so you can address exactly this vulnerability, and then you can find documentation, all that stuff. Malicious components will not have a CVE, okay? And so it's hard to find documentation and it's hard to address them, and you have to get rid of the whole component. So what are the infection methods of malicious code packages? For example, we have this typo squatting. Typo squatting is something you have something, you want to write something, okay? I'm not sure if I have the slides here. Here. Typo squatting means that you are miswriting some dependency, okay? And the infection method is here. So you're grabbing an open source component, taking the same source code, using the same version, and then you're just changing the coordinates, artifact and group name in a way that you hope that most people are writing it wrong. Huh? Then you're compiling this stuff and pushing it to Maven Central and waiting until people accidentally writing this wrong definition in the POM file, and it will be consumed. Finding this is hard because you wrote it, you think you wrote it right, you're doing a compile, you got a library, you got a binary, and everything's running well, okay? So this typo coding. So people are just using open source components with slightly different name so that you have this typo. Masquerading is something different. Masquerading, they try to imitate big projects. They're giving it a slightly different name, but they're copying the whole website, README, the whole history and all this stuff, copying mostly the source code itself, refactoring it a little bit so that the namings are a little bit different. But what you can see is that it looks like a project with a long history, but if you're looking at the statistics in this dependency management portals or whatever, you see that's not the case. So it's able to find. You have to be very careful because the whole thing looks very good and organized, but you see in statistical data, yes, something is not matching. Another thing is, this masquerading is an example here with a mount. So it's a difference between two things, what they copied and what we found. Another thing is a Trojan package. Trojan package is more or less, people are building a library from scratch because they want to deliver something interesting, okay? It could be a print library, it could be a PDF library, but it could be, for example, and this happened a few weeks ago, a hacker created a library for hackers to because for the functionality to steal Discord tokens. But the Trojan package was, yes, this library was stealing Discord tokens, but additionally, all stolen tokens were sent to the original maintainer. So a hacker hacked hackers. So this Trojan package is really, you find something, a niche functionality, and it's really nice, and it's a full package, and it's maintained, it's completely independent, it's not copied, nothing, but you have additional stuff in. Then, and this is something that is really bad and it hits all big companies during the last few months, is dependency confusion. Let's say you have a product, you're delivering your product, okay? And then it's this web archive or this Docker image or whatever. And people are able to find inside this Docker image, for example, this jar with your company internal dependency. And you just need the bytecode because then you can identify, okay, group artifact ID with this SBOM, you will get all the information anyway. And then you are slightly changing the bytecode. You don't even need access to the physical source code. And what you're doing is that you're using exactly the same group ID and artifact ID of this company internal dependency and pushing the modified version to Maven Central with a slightly higher version number. What's happening now is that the most company internally dependencies, you trust them and you see, oh, this other department had a new version, 1.6 to 1.7. Okay, we are grabbing this one. Then the request is going to your internal repository. We'll say, okay, 1.7, we don't have. I'm going to Maven Central. Oh yeah, I have 1.7, damn. And in this moment, you're grabbing internal binaries from external. So there are different strategies to get rid of it. For example, in Artifactory, you can have this resolver strategy. So priority resolution, so that you can say, okay, just internal repositories are just fetched internally and not cascading this dependency resolver mechanism to the outside or upper layer here. So this is something, and it hits all the big companies because the information about group ID, artifact ID, or whatever the coordinate is leaving the company because people are leaving the company, people are not liking this company, they are reverse engineering, and. So hijacking is something that's interesting because changing in a way. If you are going to someone who's maintaining a big project and they can take all the social media accounts or whatever, they're just taking over the whole project and they're cutting the communication channels from this maintainer. Or you have a list of maintainers and one of these maintainers is not working for this project anymore, but still in their configuration. And in some dependency management environments, it is that they are verifying over the domain. And within very easy domain takeover attack, what they can do is they're searching for these maintainers that are not active anymore. that use private domains. This private domain is maybe free to buy again. Then they're buying this domain, ramping up the email server, and authorization is done of their own email server again. So they're hijacking with this, configurations that are more or less accidentally still in this project. So there's something, but it's one thing that is happening during the last few months again and again is protestware. Protestware is that people start hijacking their own project in a way. For example, the prominent example was, I have a library, and if this library is running on a Russian or Belarus PC, then it's doing crazy things. And this was from the original maintainer by himself, okay? So hijacking is really something that is going on, and it's quite popular right now. So, okay, what can be the payloads from malicious code packages? It could be they try to steal credit card information, okay? They try to steal Discord tokens, API tokens, whatever. But what's mostly critical for you in an environment of a company is take care of your environment variables. For example, you have in your environment variables something like AWS underscore blah, blah, blah key. Then they try to fish all these environment variables. They try to catch them all, sending it back. And then people try to use these API keys for authorization, consuming resources, and so on and so on. So this is something that most people are not aware. And I found it nearly in every project that you have exactly this environment variables on a build server, in a Docker image, whatever, so that this can happen there. Connect shellback is more or less, there's a piece of software connecting to the server in the internet, asking for commands and doing it. Download and execute. You can imagine just downloading a binary like Solarwinds Hack and doing crazy stuff. And one of this execute could be, for example, crypto miner or whatever. So for you as a developer, how can you identify this malicious code packages? If you're talking about open source project, or if you're talking about compromised software inside your own company, because a lot of attacks are coming from inside the company, not really from outside. So we have, for example, this regular obfuscating stuff, okay? You have this regular obfuscators, they are easy to find. You can just let it run over your own source code. And what they try to do is they're changing variable names so that they are not meaningful anyway. They try to encode strings with hex 64 so that you can't read it. And then it's just hiding a little bit this stuff. No? You can go over control flow. So public obfuscator is just they're renaming stuff or concatenating variable names so that you're just not able to read it, okay? It's not very fancy, but sometimes it's enough to hide information or to hide it. Control flow flattening is something, you have a control flow that's going over 2 or 3 screens of your PC so that you are losing the really control flow because it's really spread over Broadway, and they try to make this control flow for you inaccessible so that the order of this is giving a different meaning as the other one. But what I really like, 2 things. One thing here is homoglyph characters. They're using UTF-8 or UTF characters that are similar to ASCII letters. And for you in an IDE, it looks nearly the same, or it looks the same, but for the computer, it's a completely different thing because they're 2 different characters. And so you have method names that are never called, or comparison of strings are completely going in the opposite direction as expected, because for the computer, it's a different string, and for you, it's not really visible. But what I really like is bidirectional control characters. And back in the days at the university, maybe you had some lectures about compilers. What you can do is you can switch the way how a compiler is reading source code from left to right to right to left and back. And if you're using exactly this and you can't see this in an IDE because there's no syntax highlighting for this shit, then what you can do is you can activate and deactivate commented stuff and so on. So it can give source code a completely different meaning because you are reading it from left to right and your IDE is showing it with this syntax highlighting, but the compiler is reading it completely different. Okay, if you want to know more about this stuff, we have this research team, the security research team, research javproc.com. There you will find a bunch of information about stuff. It's really interesting to see. For you as a developer, what can you do? What is your weapon against all this stuff? What I say is hunting vulnerabilities and malicious code packages. As soon as you have this information, the biggest weapon you have in your pocket is, whoa, slippery, is a very efficient dependency management, okay? Because this has the highest impact. I'm personally I'm recommending mutation testing. If you want to know more about mutation testing, check out my YouTube channel. I have a talk about mutation testing, but whatever test coverage you need selecting, select a very strong one, because if your test coverage is super strong and you're just changing the versions of your components and you can let it run, everything is green, you can push it to production. That's the fastest way to get rid of vulnerabilities, okay? This is really test-driven development, and very strong test coverage is a very big thing. Okay, talking about what happened around this one. There is this executive order of cybersecurity. So I spoke in the beginning about the Solarwinds Hack. The Solarwinds Hack has a huge impact, for example, to the US government. They're using tons of software, and I don't know how many servers they're consuming. It's really a lot. So, and it affected a lot of governmental institutions from the US government. So the president was able to give this executive order. What is an executive order? So I'm not a US citizen, so I had no clue about it. Searching a little bit left and right, what it is. If you're looking at the US government like a company, okay, then the US president, something like a CEO. What he's able to do is he is able to change the way the company is working internally. He can immediately do, but he can't change law. And this is exactly what is with the executive order of cybersecurity. He can change immediately the way how the government is operating, but he can't change law. And this he has done. So this executive order of cybersecurity is more or less, okay, in this, I don't know, weeks or months, every software that's consumed, built, run, operated, whatever, by the US government must fulfill this SBOM, the software bill of materials. So you need a full list of all ingredients, okay? Okay, SBOM, Dependency Manager. Okay, so what does it mean? For you, it means if you have a Dependency Manager for all tech layers, you need something that will extract this SBOM for you. We at JavaPro, we know it since a long time before SBOM was fancy, but we called it build info. Build info is a superset of SBOM because SBOM itself has just the list of all dependencies with versions and fingerprints, but has no information about the context during the time this binary was created. And this is exactly what you need for a postmortem analysis. For example, why binaries are always malicious if they are built on agent 3, okay? This is nothing you will get out of SBOM. So we have this build info, and build info itself is a superset in terms of you can store all the stuff you want to have. Agent name, environment variables, date, time, libraries, compiler, blah, 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 blah. All this stuff, what you want. You can select it more or less by yourself. You can do it on your laptop, inside your CI environment, whatever. And this build info with every build is stored so that you have this combination between a binary and the corresponding build info. This build info has two parts: immutable part. Okay, this was environment variable with its content, or this was this library used at runtime, blah, blah. And additionally, the actually ongoing vulnerability information. It means if today a build is green and tomorrow we have more vulnerability information, it will be red tomorrow without getting production, okay? And this is a good thing. So, and out of this build info, you can generate these two versions of SBOM. So you're prepared for this one. You can have this with a free tier as well. So if you want to have it for your open source project and you want to deliver SBOM, so that's easy to consume by others, just use the build information on your free tier and create the SBOM out of it. Okay, if you want to know more about this, well, on my YouTube channel, we have it. So I want to highlight a few open source projects for you so that you can start working with this stuff, okay? One is Project Salsa. Project Salsa is a documentation project from the Linux Foundation. It will give you First of all, description of the whole software supply chain security with what you can do, what are the most prominent attacks, what happened and all this stuff. Very good to read. It's an alpha state, this project, but really good to read. And you will have some levels, and then you can select, okay, I'm reaching this level because I'm fulfilling this and this requirement. The project Salsa is a project from worldwide, not selected, but a bunch of security experts that are sharing this knowledge in this documentation project, okay? And then you will find, by the way, this picture is from Salsa. So, an implementation of supply chain security for open source projects. So an open source project for supply chain security for open source projects is a project Persia. It will cover from the build environment to make sure that the build environment is not compromised until it's delivered. The short version here is you are committing to the Persia network. It's a peer-to-peer network. You're committing there a vector for the source code, and URL for whatever, and a commit hashtag. Then it will grab from randomly nodes inside the peer-to-peer network. The source code will start building it on different nodes. These nodes will share the fingerprint. So in terms of how we are creating the same binary to make sure that this build was not compromised. What's not checking if the source code is compromised, okay? It's behind, so that's included. But then if this binary is not compromised because all nodes created exactly the same binary, then it's delivered to the distribution layer, and then you can access this. So Persia is for Docker, Maven, and so on and so on and so on. And will be a gateway to trusted authorities. So we are talking with Maven Central, with Docker Hub, and. So it's an open source project donated to the CD Foundation. And have a look there. If you want to have this information as fast as possible, means that you shouldn't wait until this information is delivered by the CI environment. You should use this information maybe inside your IDE. You start editing, you want to have a PDF library, and you start editing your POM file. Then add this dependency to your POM file, and inside your IDE, you should have the whole dependency tree with a list of all vulnerabilities. So if you have this free tier, for example, or an enterprise trial, or inside your company Artifactory, X-Ray, whatever, we have this free plugin for the IDEs, for different IDEs. And then you can connect through this, and then you have this information immediately. So without writing only one line of code, you have all the vulnerability information inside your IDE. On the other side, if you want to have it on command line, use the CLI, and then you can scan, for example, there's this feature on-demand scanning. It means you're scanning on your local machine, and then you are not polluting with this not known or unknown binaries the environment. Because you're scanning it locally, you will get the list of all vulnerabilities. This report is stored in Artifactory for documentation purpose as well. And then you can decide, okay, I want to push it there or not. So it's a first line of defense, what you can have if you're creating your own stuff or whatever. Then you can see the CVSS vectors and additional security information, remediation mitigation information, source code for safe, unsafe usage of library functions, and so on and so on. A huge amount of documentation there. Or you're grabbing this stuff for the Docker desktop environment. What I want to say here with it is, at whatever stage you are, and whatever is your main tool you're working in, make sure that you have as fast as possible all the information about vulnerabilities and malicious code packages, so that you're not wasting time until some CI environment is complaining, okay? CI environment should complain anyway, so it should be implemented there as well, for sure. But make sure that you have this information. Whoever's working on source code or with its binaries should have this information as fast as possible. And there is no excuse that this is just a web UI, this is just here, this is, because you can have this information everywhere. And this is really the important thing. So what can you do next? First of all, if you like to learn more about cybersecurity stuff and you like this outdoor style, please go to my YouTube channel, the German or the English one, subscribe it. And I really would like to see you there as my subscriber. On the other side, if you want to have more webinars, go to JFrog, free webinars, as well as free workshops. If you want to have some hand-on stuff, just come to my workshop, and then we are playing around with this stuff. And if you have a jug or meetup or whatever, we can travel again. Let me know. Maybe I'm nearby in the city, so I can give you a workshop or hands-on there in your local community. If you want to connect to me, please do me a favor, don't use email. Email is a mess. Go to LinkedIn and that's it. Okay, I'm done. Then I think we are right in time. Is there any question? I will check the chat. I will check. Okay, no question here. Good. So I think we are more or less done.